All right, welcome to the last part of section 2.3. This is still the remainder and factor theorems. So today we're going to delve into what actually those factor and remainder theorems are and what they mean. Okay, so here is a fancy definition of what the remainder theorem is. This won't make much sense, but I think an example, if we see an example, that will show you kind of what this remainder theorem actually means. Okay, it says the number of tickets sold during the Northside High School football season can be modeled by T of x equals x cubed minus 12x squared plus 48x plus 74, where x is the number of games played. Okay, so this is x, number of games played. Now, it says use the remainder theorem to find the number of tickets sold in the 12th game of the season. Now, you should probably know how to do this. You could do 12 cubed minus 12 times 12 squared plus 48 times 12 plus 74, and you could do all this math out and get the answer. Okay, there's actually an easier way to do this. Okay, we can use synthetic division. So I'm going to put 12 in the box. I'm going to put 1, negative 12, 48, and 74, and then I'm going to synthetic divide, and we're going to see what we get. Okay, so I'm going to bring 1 down. 1 times 12 is 12. Negative 12 plus 12 is 0. I'm going to multiply, I get 0. I'm going to add, I get 48. Okay, now I have 48 times 12. Okay, so 48 times 12 is equal to 576. Okay, so I have 576. 576 plus 74. So I'm going to add 74, and I get an answer of 650. Okay, so I get an answer of 650. All right, now this number is very important. Okay, not only is this the remainder, but it is actually the answer to substitution. So if you were to just plug 12 in, you'd get 650. All right. So this is not only called synthetic division, but when you're actually just trying to figure out what a number is equal to, it's called synthetic substitution. Okay, so that works both ways. You can just plug a number in, okay, and the remainder is your answer. So instead of doing all this cubing and multiplying and having to make sure you worry about your order of operations, just plug it into synthetic division. Whatever your remainder is, that's your answer to your substitution problem. So if it wanted to know how many tickets are sold during the 50th season, you could just plug 50 in here and get an answer pretty quick. Okay, so that's what that means. So synthetic division is the same thing as synthetic substitution. All right. The second thing we're going to talk about is called the factor theorem. Okay. Now, this is saying, and basically I took this definition and I made it into words that you can understand. In other words, if your remainder is equal to 0, then x minus c or x plus c is a factor. In other words, for factor, roots, x-intercepts, or zeros. So if your remainder is 0, then whatever that number is, it's a root, an x-intercept, a 0, or a factor of the original function. Okay, so let's see what that means. Examples are the best way to show this. All right, so it says use the factor theorem to determine if binomials given are factors. So we want to know if either one of these are a factor. All right, so we're going to do x minus 1 first. So remember, you always have to switch the signs. I'm going to put 1 in the box. 4, 21, 25, negative 5, and 3. I'm going to skip a line, put it in the box. Okay, so let's bring down the 4. So multiply. 1 times 4 is 4. I get 25. When we add, multiply, I get 25. I get 50. Multiply, I get 50. I get 45. I get 45. I get 48. Okay, so there's that one. And now let's do this one right here. So now I'm going to do x plus 3. So I'm going to put negative 3 in the box. And I'm going to do this one again. And we're going to talk about which one of these are factors and which one aren't. Or they might be both are, or they might be both not. So bring down the 4. Multiply, I get negative 12. Okay, 21 take away 12 is 9. Multiply, I get negative 27. Add, I get negative 2. Multiply, I get 6. Add, I get 1. Multiply, I get negative 3. Add, I get 0. Okay, so there is my remainder. What the factor theorem says, that if you get a remainder of 0, that whatever you divided by, that must be a factor. Okay, this must be a factor. Okay, what is another word for factor? Root, x-intercept, 0. Okay, so if I plug this equation into the calculator, okay, into y equals, so 4x raised to the 4th plus 21 x to the third plus 25, plus 25x squared minus 5x plus 3, and I graph it, you can see, okay, that it indeed goes through x equals -3. Okay, that's the number I plugged into my synthetic division, -3. Well, if you look at the graph, it goes through -3, so it is a factor. +1 was not. It does not go through 1. So that's why you can see here I didn't get a remainder of 0. So x minus 1 is not a factor. The one that has a remainder of 0 is. Okay. All right, so let's look at example 3. This will be the last one that we do. This is a pretty short video. It says use the factor theorem to determine if the binomials given are factors of f of x. Use the binomial theorem that are factors to write in factored form. All right, so we're going to try 2. We're going to see if 2 is a factor. So 3, -1, -22, 24, skip a line, draw a box. Okay, bring down the 3. 6, multiply, I get 6, add, I get 5, 10, -12, -24, I get 0. Okay, so yes, this one is a factor. Okay, so let's see if -5 is a factor. Okay, so I'm going to try 3, -1, -22, 24. All right, so bring down the 3, -15, -16, -5 times 16. I just don't want to make any mistakes. So -5 times -16 is equal to 80. Okay, 80. -22 plus 80. -22 plus 80. I get 58. 58 times -5, is that going to add to equal 0? No, this one's not going to work. You can see that -5 times 58 is going to be a really big number here, so it's not going to work. So we have our factor. All right, so now what are we going to do with this factor? So basically what this is saying, if we want to write this in factored form, that our function is equal to x minus 2, that's our factor, times whatever our answer was here. So remember, if this is a cubed, I'm going to drop this down to a squared. So 3x squared plus 5x minus 12. Okay, so there is factored form. Now we can continue. This is a squared, so we can continue to factor this. All right, so let's see what we get here. So what times what is 3x squared? Okay, hopefully you agree that it's 3x and 3x. And now our last important number is this -12. So how do we get -12? 4, -3, -4, +3. I'm going to just try one of these. Let's try -4, +3. I don't know if this works. Remember, to see if it works, we always have to try the outside 2 and the inside 2. So I have 3 times 3 is 9x. -4 times x is -4x. 9 take away 4, we got lucky. It just happens to be +5. So this is actually our fully factored form now. Okay, so what did I do? Okay, first I used synthetic division to see which one was my factor. Okay, once I figured out which one it was, I took that factor, I brought it down, I multiplied it by the coefficients of my answer, and then I factored that answer, and that gives me my factored form. Okay, so what are my answers to my problem? This one is equal to 2. This one over here is equal to -3. Remember, we just switched the sign. And then this one, we would have to add 4 and divide by that 3. So this one would be 4/3. Oops. So this one would be 4/3. So I have 4/3, 2, and -3. Okay. We will do this example, the last example in class. I think this is pretty easy, though. I think you could pretty much do this one very easily. But we'll do this one in class. I'll see you tomorrow. Have a good night.